We want to move on now to what we call a vector. Now, a vector is described as a line that has magnitude and direction. Now, if you think back to what we did last week with the modular argument form of a complex number, what we can do is use the modular argument, mod argument form there to describe our vectors and draw our vectors up. Now, the magnitude obviously is the modulus, and the direction for the vector is the principal argument. So, way we draw up a vector, and you might have seen this in physics if you've done some there. This is a bit of vector OP. So a vector has a starting point, and then we have an end point where we've got a arrow there. So, and the arrow is indicating its direction. So the vector is moving in that direction. If we had the arrow the other end, it would be the vector PO, and it'd be traveling in a different direction. So you can see that we can have two types of vectors. One we call fixed, and that was one where we have the tail, what we call the tail, that's the tip, at the origin. So the tail's it's fixed one. It's fixed to the origin, and they move around from the origin there. The other one is what we call a free vector. So the free vector basically is anywhere. But if you notice, they're all parallel, which means they have the same direction. So that's still pi on 6, and the distance there is the same. So that is the same vector, 2 cis pi on 6. And we use our modulus argument form to describe it. So, but that every vector there is 2 cis pi on 6. It's just moved around in a different spot. It's just got a different starting spot. So that's what a vector is, and how they are described. If we have a look at some examples here, our most basic one here, 2 cis pi on 6, we saw in the last part, and all these are fixed though. So if you have a look here, these are all got the same modulus. All that matters is the direction. So remember when we said about 2 cis pi on 6, 2 cis minus pi on 6, so there's our conjugate there, written as and that'd be the vector there, and that's how we write our conjugate, because it's just changed its sign, so it's reflected in the x-axis. So if we have a look at that one, if you notice this one here, it's minus 2 cis pi on 6. Now that's the same distance there, it's just in the opposite direction. That's why it's negative. So if we have a look, remember that a negative sign is just moving in the opposite direction. So that's 2 cis pi on 6, negative 2 cis pi on 6, same angle. If you notice to the x-axis, it's in a straight line there, so you know it's going to have that same angle there. It's just in a negative direction. Same with this one, 2 cis 5 pi on 6, and even though we said it was 2 cis minus pi on 6, it could be written as negative 2 of cis 5 pi on 6. It has the opposite direction there. So that's really, it's important to be able to tell which ones are negative. For later on, we want to add and subtract, and we can see that as we move, as you can see that it moves in the opposite direction. Writing the following vectors there, so drawing them up, we see root 2 cis pi on 4. We can start to see as we go through again. Starting point would all be the origin. So where they all end up. So there's our root 2 cis pi on 4, 3 cis pi on 3, minus root 2 pi on 4, minus root 2 cis pi on 3. So you can see the direction. This one's probably a little bit shorter than it should be, but that's where they're going to end up, and that's where we can see the same distance but a different direction there. Okay, so that's what a vector is. Vector is something with a direction and a distance, and we're going to use those to prove a number of properties of geometrical diagrams, as well as be able to add and subtract complex numbers using vectors.